We often talk about the cloud, but the cloud is not magic, it's a heavy physical thing. At its core, a data center is a warehouse that turns electricity into computation. Inside, hundreds of racks run non-stop, relying on massive fiber routes and high voltage power. In fact, these campuses generate so much heat that a single facility can drink as much water as a small city just to stay cool. Right now, we are in the middle of a global construction spree. Tech giants like Amazon, Meta, Google, and Microsoft are pouring over $700 billion into this infrastructure. You can see the physical impact right here. Global capacity skyrocketed from 21 gigawatts to a projected 114 by this year. Notice that steep curve after 2018. That's the scale of the boom. Looking at the data center map, there are over 10,000 facilities worldwide. But as you can see, the US is in a league of its own, hosting over 4,000 centers, nearly 38% of the global total. Inside the US, the footprint is concentrated. The top 12 states hold 67% of all sites, with Northern Virginia alone accounting for nearly 16%. And this map is crowding fast. Between 2015 and 2024, the number of business locations of data centers exploded by over 200%. You can see the slope steepen right after 2020 as the race for AI heated up. Let's have a look at Virginia's build-out over the last 25 years. The time-lapse clearly shows the rapid development of data centers in this area. The real driver behind this dramatic growth is AI. McKinsey predicts AI workloads will jump from 54% to 71% by 2030. That shift alone adds 31 gigawatts of power demand in just 1 year. But here's the question we need to ask. When the digital worlds expand this fast, what happens to the physical world we actually live in? Let's look at the two biggest costs, electricity and water. First, let's talk about power. These facilities are massive energy vampires. In 2024, US data centers consumed 183 terawatt hours. That's over 4% of the entire country's usage. By 2030, the number is projected to more than double. The strain is worse, because they cluster together. In Virginia, data centers gobbled up a staggering 25.3% of the state's total electricity supply in 2023. Our regression analysis confirms this. As you can see, there's a clear positive correlation. More data centers is associated with a higher percentage of state electricity vanishing into the cloud. But the real nightmare is speed. Take a look at this Deloitte timeline. You can build a data center in 2 years, but upgrading the power grid takes 4 years or more. This creates a dangerous gap where new facilities drain the grid before capacity is ready. So who pays? Often it's you, because the grid requires expensive upgrades. Costs are passed down. EIA data shows prices in data center hub states are rising faster than the national average. In California, rates nearly doubled between 2015 and 2024. We see similar trends in Virginia and Texas. Essentially, your household bill is subsidizing big tech. But these computers don't just eat electricity, they also drink water. A standard wholesale center might use 18,000 gallons a day. But the hyperscale giants are different. On average, a single hyperscale facility gulps down over 500,000 gallons daily. That's enough to support 6,500 people. The problem is where they take it from. As this chart shows, 40% of US data centers sit in basins with high water stress. When we map this, the data is obvious. Footprints are clustered in the West. States like Nevada and California already have high usage. But as this overlay shows, these large bubbles of consumption are landing exactly where it's already dry. The scatter plot confirms the conflict. States with the highest scarcity, the vertical axis, host the biggest water footprints. This creates direct competition. In arid states, servers fight for the same resource as farms and households. Every gallon cooling a chip is a gallon that can't water crops. It's a tug of war between digital convenience and survival. So where does this leave us? The boom is fast, concentrated, and expensive. AI demand is hitting the limits of our local grids and water supplies. But the solution is not to stop building, but to build smarter. On the energy side, the key is on-site hedges. Tech companies need to build their own microgrids and battery storage rather than leeching off the public grid. This powers growth without spiking your bill. For water, the industry is making water-positive pledges. Players like Amazon and Microsoft are committing to return more water than they take out. They are doing this by switching to reclaimed cooling, using treated wastewater instead of draining our drinking supply. Amazon, for instance, has improved efficiency by 40% globally. This proves technology doesn't have to compete with human needs. AI is the future, but it must be built responsibly, because the cloud isn't in the sky. It's right here, on the ground, sharing resources with us. Thanks for watching.